So hello everyone, we just came back from Cartesi's workshop. It's second time we show our technology to the public, and it was quite good, right?
Yeah, very interesting. People kind of liked it, I guess, right? You were watching, right? What do you think?
Yeah, I was actually very impressed. 'Cause it's one thing to work on the core of it, and another thing to see actual applications running. So I was quite excited. So the name was building blockchain DApps with Python, right? Was that?
Yeah, with building DApps with Cartesi Rollups, with the blockchain OS. We do have most of the examples were in Python.
Yeah.
We do have a C++ example, but the interesting thing there, especially in the afternoon session, when we're talking about machine learning, that I think that was when you kind of got excited.
I didn't know what I liked the most. If it was a Titanic example, in which you're deciding, you send your information to the smart contract, and it predicts if you would survive or not Titanic. And I was having these ideas you can print an NFT a Titanic survivor or something like that. The flower one is also quite interesting, right?
Yeah. So the flower one is classical one, and actually, so we had two examples, right? One is just to show that if you want to code a machine learning algorithm, you can just do that because you can do anything, right?
Yeah.
So you can have all the loops and do Euclidean distance and whatever, and sorting things. So we had a simple classifier implemented from scratch. And then the second one was more let's leverage machine learning libraries like scikit, pandas, and stuff like that people usually use. So you don't need to code your algorithm from scratch.
Of course, yeah.
But of course, so for the first example, we classified some flowers, right, with the algorithm written from scratch. And in the second one, we were classifying Titanic using these libraries. But of course, we could classify the flowers with the libraries, no problem. Actually, they have the same simple classifier there.
Common example, right?
Yeah. But the nice thing is that you can actually explore whatever the machine learning community has produced so far, which are tons of algorithms with their pros and cons and different advanced techniques for handling different issues with the data. You have to treat data, pre-process it, lots of stuff that are involved in anything like that for machine learning.
Previous code, right? What I especially like is that we showed a bunch of different examples, and we didn't write a single line of Solidity code, right?
Yeah.
That shows that we're in the right path, meaning that we deployed the Cartesi Rollups and we have this infrastructure ready, and then the developers just the input that you send to the blockchain arrives at the Python code, the code in Python, right?
Yeah, exactly.
And you just declare a variable, set it up to the input's payload, and you're ready to do.
Exactly. Yeah. That's the whole idea to allow people to kind of abstract away the blockchain. So the blockchain is where you get the decentralization, you get the security, and the Rollups framework that we built is basically allowing this general way of just getting, proving in a decentralized way what the results are for anything. And that's done in such a general way that you just need to handle inputs and get the outputs, and the rest is taken care of. So that's where we are. Of course, we are on the blockchain space, and then when we want to interact with something else, of course, then you start to code Solidity or something, because, okay, I want this. If I win the game, then I want to just tell this other smart contract something. So of course, then there will be some Solidity involved.
Or if you want to interact
because you really want to go to that space. But if you don't want to go, if you only need to know if you would survive or not, then you don't need it, really. And that's the bulk of the logic, right? So the remaining things, just letting other contracts know of getting some input from the other contracts or triggering something, that kind of simple thing. Of course, we need that. When the blockchain is integral part. The Rollups doesn't exist without the blockchain there. It's just on top of it, so it doesn't replace it at all. It just makes things that weren't possible before possible, surviving or not the Titanic.
I was thinking that I have a bunch of friends who are developers, and many of them haven't touched the blockchain. But I feel like they could have been at the workshop coding DApp for the blockchain, right?
Yeah, so the workshop had this cool thing that we have this repository of rollups examples, and you just follow the instructions and you get things running.
Yeah.
And then you can, of course, go to the documentation, and in some examples we even have some hints of how to change things.
Yeah.
And the guy could just start hacking around, right?
Yeah. And at first I thought they would be like very confused if they deployed a code with some bugs, and then they figure out that they couldn't change it afterwards, because it still codes on the blockchain, right?
Yeah.
Still a smart contract.
Yeah.
But then we showed the host mode, which allows you to actually develop stuff.
Exactly.
Pretending that you're not on the blockchain yet.
Yeah, exactly.
I love the host mode.
Yeah,
actually.
host mode is an idea that came some time ago. I don't remember who in our team had the idea. I think it was Diego and Victor or some people down there. It's a really cool thing that not only you get this thing that you don't need to deploy stuff, right? You don't need to do all that.
All the bureaucracy
to get things running, but it's also the real beauty is that so you have this interaction between the rollups and your application, right?
Yeah.
And so instead of having something your application needed to deal with something that's very rollup specific, so okay, the data comes in, and then there are certain things that the rollups understands or the rollups wants to tell you. And then there's a very rollup specific thing, low level, you have to read some bytes here, write some bytes there. The guys came up with this HTTP API, which is just a simple way, here's your input, and it's normal for any developer. Okay, I get a request, I can send a response, and I can do this kind of thing. And the beauty of that, if the rollups framework, when it's running, somehow gets this request for you, you can do it outside of it.
Yeah.
And the beauty there is that if you're doing it outside, it's running on your local machine, just as you would develop anything that anybody has ever developed before. And so the nice thing is that if you liked using a certain IDE, like if you're Python, you can use VS Code, or many people like PyCharms, and you can just debug stuff, put breakpoints, do whatever, because it's just a normal application running on your machine. The thing is that later on you just package that thing inside the Cartesi machine. So in case of interpreted languages like Python, it's very nice in a workshop because you just copy the code inside, it's interpreted, so
but
it's exactly the same.
It's a bit slower than...
It's a bit slower, yeah. So there's this thing that for hardcore processing, you have like two options basically. And either you use some library that somebody already did, and that's probably compiled to native binaries, right? Or you need to do it and compile it.
Yeah.
But usually, in the Python landscape, you can just use these libraries.
Yeah, I was actually quite jealous to see them import NumPy, because it reminds me of the many smart contracts that you had to write, and sometimes you have to write like math functions, calculating the logarithm of something.
That kind of thing. So it's so many things that actually in some of the first examples, which are really nice to see, that a lot of things are just built in. You don't even need to think about them. Yeah. So you can, like reading the data set, reading from a CSV file.
Oh, that was the incredible part to me. When you loaded the CSV file, I was like, oh, you can actually just like import it.
You can just import a CSV reader, and you can just read them, and if it's a string, you can convert it to float, you can do whatever, and then you can do like in the KNN example that we were just implementing from scratch, the entire thing.
Yeah.
It just computes distances and just sorts stuff, and that's all there. Like this is what regular. Some of it is not even a library that you import. It's just regular Python code.
I feel like sometimes I've been coding for blockchain for so long that sometimes I forget how convenient these things were back in the day, right?
Yeah. Like, we're back that they are. This is what people actually
use.
Are
outside of blockchain.
So the thing is, for me, like I've been in the blockchain world for almost 2 years only, and it's really shocking sometimes when you start coding smart contracts and things. The first impression is well, there's the thing that you need to learn the the language and how to deploy stuff is really complicated sometimes. But the thing is, then you start coding, you start getting really happy. Oh, this works, and okay, you just have a mapping there, and your state changes, and oh, nice. And then okay, let's start doing something. And when you start doing something, you start hitting the wall.
Yeah.
So you can't do floating point math. You can't. I remember the worst thing for me was that when I had this contract, it was getting increasingly complex. It was a thing with the turn-based game thing.
Yeah.
And so increasingly complex, but from a solidity point of view, right? Because it's just like some guy that did a move, just a payload of data, and I'm just registering that this guy did a move, this guy did a move, this guy did a move, and then game is over. Yeah. It's kind of really simple. But at some point I did one line extra of code, and then it wouldn't compile anymore. Simply wouldn't compile anymore because the contract was just too big for a block, and I needed to chop it up somehow, change your entire contract, everything, so that it fits now. And then I remember the stack too deep when I started facing that. My God.
Oh yeah, at least I think they're like solving that in the next Solidity version. I think they stack too deep.
But it's a kind of thing that it tells exactly, they're fixing that, but that tells of the immaturity of the thing.
For sure.
You tell that to somebody who uses C++, for instance, it's been around for 30, 40 years. Yeah. What? You can't have that, you can't have a certain number of variables, is not allowed. There are things that are maturing still.
I think sometimes we forget that, because when you start coding for blockchain, we enter the mindset.
Exactly.
So we only allow ourselves to think of applications which are simple enough to be able to run on that infrastructure. So I think that's what I'm very excited with about with Cartesi, because it allows us to actually like start thinking about real applications again, right? Applications that like complex financial models or like order books even, right? So yeah, I think sometimes we're lost in these bounds of limitations that we accepted as immutable, but they're not, right? You just showed us today on the workshop that you can actually run a Python machine learning classifier on the blockchain, right?
Yeah, I think some basic things that come to mind is like you get used and you simply don't think about parsing a JSON string. And how come how can that be possible? I mean, everything everywhere has some data structure, and I know you don't have data structure. Like I can't like do a binary tree search or something like that. R trees, I was talking about R trees. If you have like this spatial quad trees or R trees for searching fast for a large amount of data, you can't have a large amount of data anyway.
You cannot sort an array.
If that
array is too big, then
So it's a kind of thing that for the people who are just arriving in blockchain, they really get so scared that they just shy away from it.
Yeah.
And one thing that we've been seeing, talking to partners and other people, is that actually there are like tens of millions of people who really they're dying to get into the blockchain world and contribute to the space, but they just get blocked.
Yeah, I think about games a lot, right?
Yeah.
Because game is a thing, like a game has to be fun. And it's very hard to code a fun game when you're limited to what the blockchain currently gives you, right? And I think games are like a perfect example for blockchains, because games, decentralization is great in games. They involve a lot of assets, so there's a financial aspect to games. And I think you even mentioned that on the workshop, the whole NFT, like the logic that generates the NFTs being centralized, just because a game to be fun has to exist in this infrastructure, right? And with Cartesi machine and bringing these like real libraries and real tools to the blockchain development, you can actually code the logic of a game in a verifiable way. So it's like a smart contract that runs a proper fun game, and that's something I get really excited about.
Yeah. So when we're talking about games, that's something that's very common, right? Play to earn, things like that. So, as you said, there are economics involved, or maybe like it could be I don't know, bets or something like that, NFT minting, etc. So maybe you could talk a little bit about how assets get in and out, and how the rollups, the Cartesi Rollups interacts with the rest of the...
Sure, yeah. So I especially like games because I've played many games in my life, and sometimes I would waste thousands of hours in a game, right?
No,
and
wasting.
earn,
You
not
were
waste,
enjoying.
having fun, yeah. But acquiring all these like important items in the game that were super valuable to everyone else, but I couldn't trade them because they were not really mine, right? So assets on the Cartesi machine is quite interesting because there are two types of assets, right? There are assets that are created inside the game, and there are assets that come to the game, right? So if you want to represent like Ether in a game, then you have something we call a portal, which is you deposit Ether on the layer 1 smart contract, which works kind of like a bank. So we call it portal. So we deposit money there, the assets are locked there, and they appear on the layer 2. So they appear on your game. And then suddenly you have this currency on the game that you can use to trade with other players, to buy swords or armor. And you can, so that's how things get into the Cartesi machine, right? Into the layer 2 world now, the universe of layer 2. So it's through the portal, and the portal supports any ERC20, it supports Ether, also supports NFTs. So you could have like, if you want to have a museum, you can have a DApp in which people deposit their NFTs on the portal, and then have an exhibition to show your NFTs, and people can pay the entrance fee with Ether, also depositing it on the portal. But of course, if something enters the layer 2, it has to come out as well, right?
Eventually.
So eventually you have to unlock.
Unless they like it so much in there that they never leave. But
yeah, fair enough.
But they must always be allowed to, right?
Yeah, they must always have the option to leave. And the way we implemented that on the blockchain side is by something called the vouchers, which is so the rollup works, as you know, by we receive a lot of inputs on the base layer. These inputs get processed off-chain on the DApp itself, and then every once in a while the DApp goes back to the blockchain just to checkpoint the state of the DApp, right? Look, this is what happened on the last inputs, right? Last group of inputs.
Yeah.
And when they checkpoint this data back, they also checkpoint all the vouchers, which is basically a permission for you to execute a function on the layer 1, right? So if you send an input to the DApp saying, look, I want to get my Ether back. I want to leave.
Leave the game.
Yeah. So when
I'm exiting the casino.
Yeah.
And okay, these are my chips, and I just want to cash out.
Yeah.
Right?
Or I just sold my armor to someone for a few.
You're always
few
into
ethers.
fantasy games, and
yeah, I like those. But yeah, so you tell the DApp like, look, I want to take my money back to layer 1.
Yeah.
And then when the DApp checkpoints the state back on the blockchain, it checkpoints together this voucher telling you that, look, you can come to the portal and you have with this cryptographic proof, you can take your money back. So that's a voucher. And the vouchers can be used for a lot of different things.
Yeah, it's much more than just getting assets out, right?
Oh,
you can do other
it's
side
arbitrary,
effects, right?
Yeah, you can call any smart contract that you want with any payload, right?
Right, so it's basically an address of the smart contract you're calling?
Yes, and the payload, which is a...
And the payload defines with the method you're calling and the parameters.
So it's a generic call. So you could have a layer 2 DApp that trades something on Uniswap.
Right.
So after everyone agreed on the DApp to do something, then you go to Uniswap and realize, like, I don't know, trade a token for another token. So it's quite generic and quite versatile, right?
Right.
But the vouchers are like actions, things you can do. And we also have another type of output, which are the notices, right? So the notices are things that you can prove. So maybe I want to prove to a random smart contract that I won 5 chess tournaments on a Cartesi chess the app, right?
Right.
Because maybe they're giving me a trophy for that.
Yeah.
So the notice is a...
Maybe I just want to check into the chess masters conference, and who do you think you are? You look,
look, I won 5.
I won 5 tournaments in Cartesi chess DApp. Okay, yeah.
Yeah,
okay,
and I really like those because they're like super versatile, and they come accompanied by cryptographic proofs. So you can never execute a voucher that was not emitted by the logic running off-chain, right? You can never prove something that didn't happen. So yeah, so that's the way we communicate.
Do you want to talk more about how does that proof come out? Because it's not something. It's something that's only happens when things are kind of like consensus has been achieved, right? Or something.
Yes.
Because to be sure that this is for real, right?
Fair enough. So at Cartesi, we are an optimistic roll-up, right? So that means that someone proposes this checkpoint that I was talking about. And the checkpoint...
But proposing a checkpoint, you mean this is the state of the application now?
Yes.
And these are the outputs, right? These are the vouchers that people can execute. These are the notices. So this is information
exactly, yeah,
related to that state.
So maybe let's talk about the whole life cycle of a DApp, right?
Okay.
So the DApp starts off-chain, and the entrance to the DApp is the base layer. So it's the layer 1. Let's say Ethereum, right? So you communicate with the DApp by sending messages on Ethereum, and then you can send inputs. You can send it by yourself, or you can aggregate inputs with a lot of people, and you can compress using any kind of compression that runs on Linux, right? So that's also a big thing. But then you give these inputs to the blockchain, and then these inputs make it to the Cartesi DApp. And the Cartesi DApp.
How do they get there?
Oh, you know better than I do, right? So we have the validator node, which is something that you run that is always watching the blockchain. And every time an input arrives at the blockchain, this validator node listens to the event, looks at right now the call data, but there's different ways of doing that, gets that input, puts it on the Cartesi machine, which is the deterministic.
Yeah, so you have a network of layer 2 nodes,
yes,
which are all watching the blockchain, the base layer.
Yes.
And when there's an input there, all of them know it, and then they get it, and they send it to the backend, which is running all these layer 2 nodes.
Exactly, yeah. So after a few inputs, we call it an epoch, which is like a time span in which you receive inputs, right? After a bunch of inputs, the validators, they advance the entire state of the machine, and they checkpoint that the result of that advancement or those advancements on chain, right? So they go back to the blockchain and say like, look, all these inputs that came since my last checkpoints, they result in this state.
And what's this state?
This state is a mix of 3 things. The vouchers that were generated by all those inputs, the notices that were generated by all those inputs, and the state of the machine. So a Merkle hash that summarizes the entire content of the address space of the Cartesi machine that is running the DApp.
32 bytes to represent an arbitrarily large full computer, right?
Yes, with somewhat
memory,
infinite number of vouchers, possible vouchers and notices. Yeah, just in 32 bytes.
Yeah,
that's quite
cryptographic
impressive.
magic.
Yeah.
So when they checkpoint the state, so go ahead.
Yeah, so they checkpoint the state on the blockchain, right? So this is open, I can do that. I go there, like, look, the state is this one. Then since it's optimistic, this checkpoint doesn't come with any cryptographic proof. So we cannot accept it as real.
Yeah, because anybody could just run whatever and say, okay, I just reached this state and like I can withdraw $1 million now.
Exactly, yeah. So what happens is like someone suggests a state, like, look, this is the state. But since this checkpoint is deterministic, everyone off-chain can figure out if the checkpoint was honest or not.
Because the Cartesi machine is deterministic, so all the inputs that come in, they must reach the same state, so the same hash, and exactly the same voucher and the same notices. Anything is different, we have a problem.
Exactly, yeah. So what happens is like you suggest a checkpoint, and then
we don't have a problem. But somebody did something that they shouldn't, right?
Yeah, exactly, yeah, true.
Yeah.
So you suggest this checkpoint, and then we allow some time for everyone to check. And if, as you said, if someone finds what you suggested funky, they can go there and they have a dispute that runs on chain. and that's the interactive fraud proof
But
that
not
we were
fully
talking about.
on chain, right? It's
Not
just-
fully on chain, right?
Yeah.
Yeah, but it's an interactive verification game, which can prove I cannot say that word.
Arbitrarily.
Thank you. Large computations with a limited number of steps. So that's quite cool. So that's how we ensure that these vouchers and notices are always.
So after the if there were any disputes or anything after that passes, then you get the proofs.
Yeah.
And you can withdraw, etc.
Yeah. So after this challenging period was over, that checkpoint gets finalized, and then you can execute the vouchers and the notices and so on.
Yeah.
So yeah.
But even before that happens, even if you don't have the proof, if you have like an infer something or some node that either you're running or that you trust, you know that the notice that if that guy, if you have some level of trust in that node, that you know that it's not misbehaving, like if he just said that the guy is entitled $1 million, then you know it's true because you are running the thing. Then even if the proof is not there, you can maybe do something with that information, right? You can show it in your front end or do whatever, right?
It's a very interesting scenario because everyone off chain knows what the honest result is, and can enforce that honest result will eventually be the real result.
Yeah, but this is a tricky thing about optimistic rollups that sometimes gets overlooked, right? So that finality where you can prove to anybody in the world that this is the final state. This is one thing that has its uses, but also to just be sure about the information, it's usable in several other ways. So even if before you have all the dispute resolved, this could be just enough for many applications. Right?
A cool example is the liquidity provider, right? So I show you like, look, I'm trying to withdraw my money from this DApp.
Yeah.
And as soon as this checkpoint gets finalized, I'll have my money.
Sure.
But I need it today to pay rent.
Yeah.
So I can lend you the money for a tiny fee.
Because you're running the node, the lender is running the node, and he knows that it's true.
Exactly. He knows he can enforce the validity of that. It's just in a week he'll have the money for sure. So he can front you the money for a fee. So in that sense, the finality problem is attenuated.
Yeah, and one thing that's like nice to learn also is that to keep in mind is that so this lender was there and he's running a node. He knows that you have that money.
Yeah.
And it doesn't matter if all the other nodes in the world decide that you don't have the money.
Yeah.
Because you run it honestly, you get you know that that's the correct result. And if everybody that you're 1 in a million, you can actually prove to everybody else with interactive dispute resolution. You can actually tell to people, look, this is the correct one. I can prove it.
Yeah.
And you can prove everybody wrong. So it's not. Sometimes you get this misconception that it's like a 51% attack. There's no such thing.
There's
right?
no such thing.
It's any trust guarantee. Right?
Any trust, yeah.
Yeah.
So that was amazing. An amazing workshop. I was really excited to see things running, and see like all these crazy applications that were not possible before.
Yeah, and this all possible with all the stuff that you guys built underneath, right?
We built, right?
Yeah, we built together.
So this was a conversation with Milton right after the workshop. See you guys around.